You know, we've seen this kind of example before. Okay. Namely, a bag of marbles, okay? Let's suppose it contains 3 gold marbles, okay? 6 silver marbles are there as well, and 15 red marbles. We're also assuming that the marbles, you can't tell the difference between them. Sorry, they're indistinguishable from each other besides their color. What I'm trying to say there is, if you reach into the bag, you cannot tell which marble is which by just feeling them. Sorry about that. I forgot to silence my phone. But you cannot tell which marble is which. You can't tell by feeling it, by feeling the marbles, that is, which one is red, which one is silver. That's what I'm trying to say. You can't distinguish between them unless you actually look at the marbles themselves. Okay, so let's suppose we're drawing, that is, we're taking 2 marbles from the bag with replacement. Okay, what does that mean with replacement? It means we take a marble out, we look at it, note the color, and put it back in. What's the probability that both marbles are red? Well, let's let A be the event that the first marble is red. B is the event that the second marble is red, okay? Well, what's the probability of A? Well, there are 15 marbles in the bag, right? And there are 24 marbles in the bag altogether, okay? The probability of A then would be 15 out of 24. That's what we get. All right. What about the probability of B given A? Remember, we're trying to find the probability of A and B, right? That's what we want to know. We want, and from here, this is what we have to calculate. Okay? This is what we have to this is what we calculate. All right. Okay. So the probability of B given A. So in other words, given that the first marble was red, what's the probability that the second marble is red? Well, remember, if we put the first marble back in the bag, right? Then when we draw the second marble, there are 15 red marbles, and the bag has 24 marbles in it. So again, we get 15 out of 24 for the probability. That's what we get again. So in other words, these are both equal to each other. Okay, so they're equal to, excuse me, they're equal to each other. So the probability of A and B from here, right? We just take the product, which is this. So that's the probability. All right, that's good. Okay. So now, what's the probability of B? Okay, now, here's something else I want you to notice. Notice that here, this is the probability of B, given that the complement of A has occurred. So we're finding the probability of B given the complement of A. So we're finding the probability of B given that A has not occurred. Well, if A did not occur, what does that mean? The first marble we picked was not red. Okay, so but again, what happens here? It's with replacement. So we take a marble, note the color. In this case, it's not red. Okay, so it's either gold or silver, but whatever it is, we're going to put the marble back. It goes back in the bag. Okay, now because it's back in the bag, right? And we choose the second marble, again, we get 15 out of 24. Because again, when we choose the second marble, there's 15 red possible marbles. So there's 15 favorable outcomes. And there's 24 marbles in the bag. So there are 24 possible outcomes. This is what we get. But notice these two are the same. And since they're the same, that actually tells you that A and B are both independent events. They're independent events. Okay. Are there any questions on this? Okay. Now, this is the same scenario, but let's suppose instead, though, as you can read here, we're drawing 2 marbles from the bag, right? But it's without replacement. So again, in this case, we take the first marble, note the color, but we don't put it back, though. We do not put the marble back. All right, well, what's going to happen then? That is, what's the probability that both marbles are red? All right, well, in this case, again, we're gonna let A and B be the events as before. A is the event that the first marble is red. B is the event that the second marble is red. You know, just like before. And just like before, the probability of A is 15 out of 24. But again, we want the probability of A and B, right? So we need to find the probability of B given A. We want that. What is that though? Well, so we're assuming A is occurred. So we're assuming on the first that the first marble we chose was a red one. Okay, now what? Well, now there's one less red marble, right? There's 14 red marbles in the bag, and there's 23 marbles altogether. So what's the probability of B given A? 14 out of 23. 14 out of 23. Again, we're assuming the first marble we picked was red. Okay, that's what we're assuming. So there's one less marble altogether, and there's one less red one. So the probability then of A and B, right? That's the product. It's 15 over 24 times 14 out of 23, which is this product. Okay, so that's good. Are there any questions on this one? Okay. All right, so here, right? Now, we just found the probability of B given A, right? You know, we just found that. What about this, though? The probability of B given that A has not occurred. Well, if A did not occur, the first marble we chose was not red, right? So it wasn't red. Okay, so there are 15 red marbles in the bag, but there's still one less marble. So there's still only 23 marbles. So this probability becomes this. 15 out of 23. So that's what we get here. So that tells you these are not the same. So in this case, A and B are not independent, mostly because it's without replacement. So it's without replacement. All right. All right. Any questions on that? Okay. This was actually something from the first exam. I thought it'd be good to do this. So let's suppose we have a box, right? And let's suppose its dimensions here are length, width, and height. So the box, again, has length, width, and height. You know, this is the dimensions. We're going to find its volume in cubic feet and cubic inches. we're going to find the volume in cubic feet and cubic inches, okay? That's what we're going to do. All right, the volume of the box, right? The volume then, right? Well, we have the length and the width, and we have the height, all right? So really then, what is the volume? Well, without actually carrying out the multiplication, we have 6 feet times 4 feet times 5 inches. 6 feet, 4 feet times 5 inches. Well, let's first get the volume in cubic feet, which really means we have to convert inches to feet.